Let's begin with the list object. A list object is an ordered sequence of other objects. You can see here that my list has 3 integers and 3 strings. We can of course put them in any order. We don't need to have integers and then strings, and in fact usually we're not going to see what we would call heterogeneous objects. We're usually going to see objects that are all of the same type. So any one of these lists can have any objects within it. That order is kept in the list. The list will retain its order. And so there are different things that we can do to the list that reflect that it's an ordered sequence of items. For one thing, we can easily get the len of the list. And of course, you'll remember that the way we used len before was with a string. A list and a string are very similar in a lot of ways. If we had a string that was A, B, C, D, that len would be 4. This particular list has 4 string objects, and so its length is 4. Again, keep in mind that the objects can be anything and can be of any type. It really doesn't make a difference to Python what object types we put in there. The len will simply tell us how many there are. Because it is an ordered sequence, we should also be able to subscript the list, and we've seen this before. We probably want to reiterate the fact that the last item in a list is denoted by a negative subscript. So of course the first item in a list starts at 0. That would get us A in this case, the first item in X. The second here with last is -1. -1 counts from the end. So if I wanted to get the second to last, I could easily do that with another a negative subscript that is counting from the end. Another thing we can do, similar to a string, is get a slice of items. So if I wanted just the first 3 here, I could easily get that. Oops. And I would get the first, second, and third objects within that list. Of course, don't forget that the slice indices follow the rules that we saw with the string, namely that the first item starts at 0, so item counting begins at 0, and you can see that's true on line 7 as well. The first item is A. Item counting begins at 0, and the second index, in this case the 3 index, is the index of the item not to be included. So A is 0, B is 1, Cheery is 3, David is 4. If we were to ask for just the first 2 items, we would ask for, oh no, I'm wrong. I'm sorry. I was right originally. 0, 1, 2, and David is 3. So let me count that again. A is 0, B is 1, Cheery is 2, and David is 3. If we ask for items 0 through 3, what we're really asking for is items 0 through 2, not including 3, which means that you should be able to tell me which items will be included if I do something like that. Obviously, you could just slide up from what we have, so let me give you a better one. Which items would be included here? The answer is 2, 3, and 4, but not 5. 0, 1, here's 2, 3, and 4, but not 5. 2, 3, and 4, but not 5. And that's how a slice works. Of course, again, we should make really clear the parallel between a string and a list of items. A string is a sequence of characters. A list is a sequence of objects. So the len of a list is very much analogous to the len of a string. Instead of the len being a number of characters in a string, a len of a list is the number of items in the list. You can see we have 6 items. Subscripting works just as we said before, although we're introducing the negative subscript here. And then finally, slicing also works very much analogous to a string. If we ask for a certain number of items in the list, we're getting items from the list, that is, the objects that are in the sequence of the list, rather than characters in a string, which is how a string slice works.